Hello, and welcome to JavaScript Marathon Training. We are thrilled to bring this back to you this month after our inaugural marathon training sessions back in April. My name is Tara Hampton, and I will be your host for today's sessions. We are kicking today off with our React track. Today's session is React Suspense. Currently in alpha phase, today you'll see some of the fundamentals of how it works and how it can help improve the user experience. Today's trainer is Kent C. Dodds, educator and content creator on egghead.io, front-end masters, testingjavascript.com, and more. You can find him on Twitter using the handle shown at the bottom of the screen. Please don't hesitate to get in touch if you have any questions or feedback from today's session or just in general. And of course, we couldn't do this without our sponsors. Our sponsor today is This.Labs, your partners in modern digital transformation. We specialize in mentorship, consulting, training, and staff augmentation for enterprise organizations. You can find out more at this.labs.com or send us an email at hi@this.co. Do you find keeping up with the constantly evolving technologies a struggle? Do you want to bring your team up to speed on one of the latest technologies? This.Labs offers personalized training programs to suit your organizational needs, ensuring you and your company stay on the leading edge. You can contact us today at hi@this.co to set up your complimentary needs assessment. And if any of you know anything about This.Labs or media, you know we have regular events online. You can tune in every Thursday of the month for a global React meetup. This.'s online meetups are an amazing opportunity for developers and enthusiasts alike to engage with the global tech community, no matter where they are in the world. You can get more information on each month's session and register to join at reactjsmeetup.com. So Kent, I am going to kick it over to you to get started on React Suspense.
All right, thank you so much. The first thing that I wanted to show is epicreact.dev. It is, yes, this is a self-promotion, but if for no other reason you want to come here because we have some really cool animations, check out that. I'll do that again. Isn't that awesome? And watch the rocket. I didn't build these, but I think they're amazing. But go to epicreact.dev to learn more about this. What we're going to be talking about today is React Suspense, and I'm going to be using the material that I have for teaching about Suspense on React Dev, or Epic React Dev. So you can, you're going to get a little bit of a preview of what is to come on Epic React Dev. So yeah, we're talking about React Suspense. It will come eventually, hopefully. We've been waiting for a while now. And you know, as excited as I am about React Suspense, I'm more excited about being able to actually use it. And so it's a fundamental shift to how we think about loading states and error states in our applications. And I think that it's going to make a huge difference for the productivity that we can have as we build our applications. Most of the stuff that you're going to be doing with React Suspense will actually be built into libraries. And so you won't, the APIs that I'm going to show you here are not something that you're probably going to be using yourself. But I think that it's really helpful to understand how something works, or like the abstractions that you're going to be using, how those things will work. And also, if we don't ever talk about the fundamentals of how things work, then who's going to be building those APIs? So 1 second while I just make sure that everything is going okay for my kids here. My wife and I had a scheduling conflict, and she got a dentist appointment right now. So my kids are watching Netflix, and I just had to make sure that the right episode is playing at the right time. So Let's go ahead and get started. Before you can use React Suspense, well, let me take a step back. React Suspense has actually been around for a few years. It's been already released, and we use it with lazy loading of code. You can use React.lazy. You need a suspense boundary for that. But for data fetching, which is what we're going to be talking about today, you can't really use it in any practical setting without enabling React concurrent mode. So they kind of go hand in hand. And that's the first thing that I'm going to show you here in this training is how you can enable React concurrent mode. So on the right here, I've got basically what's showing on the left. So we've got a React app, and it's being rendered the way you normally render React apps. I can say, hello, React friends, and save, and that will automatically reload and everything. So to enable concurrent mode, you have to enable it for the entire route. Route of your application. So you can't say, okay, this part of the React tree is going to be concurrent mode and everything, and this stuff is still the old stuff. No, you have to opt into it for the whole route. And normally, like for most people, you only have one route in your application, and so you basically opt into concurrent mode for your whole app. Luckily, if the dependencies that you rely on and you are writing idiomatic React code, then it shouldn't really cause any problems to enable it. But yeah, let's go ahead and take a look at how you enable React Suspense or React concurrent mode. So to do this, you're going to use a new API on React DOM called create route. And with create route, you pass it a element that you want to have for your route element. And then this is going to give you back a root object, and you can use root.render app. So you say, I want to render this thing to this page at this route. So like it doesn't look very substantially different, but under the hood, it's doing a lot that's different. So yeah, like ultimately it ends up rendering the same thing. There's not a whole lot of difference here. There's another interesting thing about the route, and that is unmount is also available. And so you'll notice we mount it and then we immediately unmount it. And so yeah, that's pretty much all there is to enabling concurrent mode. And I do have a blog post about this if you want to go learn more about the process of doing this. I neglected to mention that this API and all the APIs that we're using are not available in the current version of React. You have to install the experimental version of React to get these APIs. And yeah, and your fate is in your own hands when you're using the experimental version of React. So I wouldn't recommend actually shipping anything to production with concurrent mode. So let's move on to our actual like using suspense and concurrent mode. So we're going to be using a fun little API to get Pokemon information. I'll show you what we're actually going to build just so we're all on the same page. So here we start out loading with a loading indicator, and then we can render Pikachu's information here. Okay. So how do we get Pikachu's information into this Pokemon so we don't just have this to-do stuff here? Well, the way that we typically do this is we'd come into the Pokemon info, we do React, use effects, and we'd have to use state and a bunch of other things. But we're not actually going to be using the React use effect. Instead, we don't have to wait until this component's actually mounted before we start making the request to get the Pokemon information, right? So I can bring in our fetch Pokemon utility function that's going to asynchronously go get the Pokemon. And I can call that right here to say, hey, let's get Pikachu. And then let's just console log what we get back from that. So this is going to be, we'll just say P, not padding bottom, but P for Pokemon, console log that, and we'll get a refresh. And here it is. There's our information. We get attacks and special. We get all the information that we need. And let me bump up the font size for that so that you can see that more readily. So somehow we need to get the information that we get from this request into our component and trigger our component to re-render, right? So this is what Suspense allows you to do. It allows you to say, hey, this component actually doesn't have the data that it needs yet. We need to wait for this request to finish before this component has the data that it needs. So what we're going to do is I'm going to say, assign this to Pokemon Promise. And then if, or sorry, let me take that a step back. Then here I can say throw the Pokemon Promise. That's the API. Woo! We're throwing promises. Now, my first thought when I saw this as the API was, now hold on a second, doesn't throwing, like I always heard that throwing in JavaScript puts the JavaScript engine on the slow path because it like has a hard time optimizing that or something. There are two things. First of all, that's like only partially true, and it's not significant enough to even really discuss. The second part of it is when you're using Suspense, normally you're doing something asynchronous. And if you're going to do something asynchronous, then it doesn't matter how slow your code is because the asynchronous part of that is going to be so much slower that it's negligible. So this is the API. We're basically saying, hey, React, this component that you're trying to render right here is not ready to render. We need to wait for this promise to resolve. And then when that promise resolves, then React will say, okay, well, you should be ready to render now, so I'll re-render you. But of course, we're throwing that promise. So we need to have some sort of condition to say, hey, don't throw this promise if it actually has already resolved. And a good way to do that is to make a variable that will store the data. So we'll say Pokemon equals the Pokemon information we got. Then we can get rid of this, and we can say, if we have the Pokemon, then we can continue. Otherwise, we'll throw this promise. So we know that it hasn't resolved if we don't have the Pokemon yet. But if we have it, then we're good, and we can continue to render. And so if we save that, then we're going to get another problem. And this one's pretty easy to solve. It says, hey, Pokemon info suspended while rendering, but no fallback UI was specified. That's basically React saying, hey, listen, I realize that you're not ready to render this component yet. You have this promise that you're waiting on, but I don't know what to show in the meantime. Like, what I'm like, what do you want me to do with this? Just show a white screen? No, I don't think that's what you want me to do. So what we have to do here is add a React Suspense boundary. And this is the component that's been around for a long time. We've been able to use this for lazy loading of our code. And so now we're just using it for what we should render in place of the component that's suspending while we're waiting for it to finish. So we'll provide a fallback, excuse me. And here we can just say div loading ... And let's save that. There we go. Loading, and then we've got the Pokemon there. And like that's it. This is all that you need to know really about concurrent mode and suspense. The absolute fundamentals. This is as simple as I could possibly make it. So just to kind of review the concepts in general, and of course, like this is not what you want to write in your production code, right? Like nobody wants to do this. Don't worry, you won't have to. Like I said, most of your abstractions will have all this baked in, and you won't need to worry about a bunch of this stuff. But like this is the fundamental idea of suspense. The idea of suspense is you have a component that doesn't have the information it needs to render the stuff that it's going to render. That information is coming asynchronously. And so presumably that asynchronous request has already been fired by some mechanism. And so you simply need to throw a promise that will resolve when this component is ready to render. So when it does have all of its data. And when you throw that promise, React will catch it because React is calling your function after all. React will catch that promise. It will say, oh, this isn't like a runtime error or anything. You're throwing a promise. So I'm going to assume that means you want to suspend this component. And I'll attach my own then handler to this promise so that when this promise resolves, I know that you want to re-render this component. And while that's happening, I'm going to render this fallback in its place so that the user has something to look at while we're waiting for the promise to resolve for this particular component. When it does, then I'm going to trigger a re-render, and hopefully you've done something so that you don't throw that same promise again. Otherwise, you'll just end up in an infinite loop and it won't be useful. So what we did was we sent the Pokemon data when this promise resolves. And so with that set, we don't throw the promise, and instead we return the UI. So that's basically it. I just noticed that Lucas is asking where to find the code for this, and I include a link to the repo here at the very beginning. Just GitHub Kent React Suspense. So feel free to dive in if you want to play around with this stuff. All of this stuff is actually built for exercises. So if you want to go through this as a workshop on your own, that is totally cool. You're welcome to do that. Okay, so what about errors? That's the next thing that we want to talk about here is like, what if there is some sort of error in the process of retrieving this Pokemon information? So like, let's say I misspell Pikachu, right? So that's going to result in an error. And if I look at my console, then I can see that the response that I get back here doesn't have any Pokemon here. So yeah, that's not super awesome. So I'd much rather have some sort of indication here that we tried to load and we failed to load. So the way that you go about handling errors in promises is on this then handler, your first argument here is the success handler. The second callback is your error handler. So we're going to do the same thing here. We'll just make another variable for Pokemon error. And then we'll say that Pokemon error equals that error that we get from this request. And then if we have a Pokemon error, and we know that the request failed, right? And so we could render something like, hey, bad request, or something like that. That would work out. It'll show bad request. Okay, so that's great. But one of the things that I really like about React, as far as error handling is concerned, is I like that it has the ability to render or handle runtime errors like really declaratively with error boundaries. And this is a feature that's been available for a very long time. And so I'm going to use an error boundary, and I've got one built in here that I'll just give you a quick tour of. It's not super relevant to what we're discussing here, because error boundaries is an old feature of React. But if we come down here to, I've got a bunch of utilities in here. You can feast your eyes on it. Sometimes it's kind of fun. But we have this Pokemon error boundary that's built on this error boundary component that we're getting from React error boundary. Sorry, I've just got something in my throat. And React error boundary is honestly de facto standard. I would never build my own error boundary, except for the fact that I kind of built React error boundary, or I maintained it anyway. But I would just use React error boundary for all your error boundaries. They're great. But yeah, so Pokemon error boundary is just built on top of that to give a nice fallback UI. So that's what we're going to be using for handling our runtime errors. So here I'll say Pokemon error boundary, and we'll wrap this just like we did with our suspense boundary. Just everything goes inside of that. And now Pokemon error boundary can handle our runtime issues. So if I throw a new error, whoops, oh no, then our error boundary handles that for us. So it can handle our runtime errors, but it can also handle our suspense errors. And so here I can throw the Pokemon error. And now, rather than having to worry about some declarative or some UI that I want to have rendered when there's an error, I can just throw that error and then let the consumer of my component decide what they want to show if this component doesn't get the data that it needs. And so that gives me a really nice declarative API for handling errors and handling loading states. And let's take this a step further, where with our loading state, we actually also have a nice or a nicer fallback that we can use. So I'm going to bring in Pokemon info fallback, and I'll stick it right in here. just to kind of give us an idea of what is possible. So it's not just like a silly loading thing, but you could actually give a shell API or a shell UI to your users to give them an idea of what is to come. And so it's less jarring when that data ends up loading in. So that's how you handle your errors. You just make sure that you're handling the rejection of the promise and storing that rejection, that error value somewhere that you can then within your component throw so that it can be handled by an error boundary. So actually there's nothing about suspense in that particular piece. That's all like regular React stuff. If you can do this with even if you're doing like hooks with use effect and everything. If you wanted to leverage the error boundary rather than like saying, here's my state for the error, go ahead and render some state, you could actually just throw that error during the use effect or inside of the function body, and then let an error boundary handle that. And I actually prefer that personally. Okay, great. So the next thing that I want to talk about is, as awesome as it is that we have the ability to throw errors and promises around. Actually, no, it's not awesome. I don't like that. That is not a fun API to deal with. So we're not going to deal with that. Instead, we're going to build a generic solution for this kind of a problem. So I'm going to make a function here. We're going to call this a resource. So we're going to get an object back that we'll just call a resource that allows us to read that resource's value, and it's going to look amazing here. I'll show you. It makes your code look successful, or it makes your code look synchronous, which I think is awesome. So we'll call this create resource, and we're going to take a promise as part of our create resource, and then we'll move this code that we have up into create resource, and we'll genericize it as much as possible. So I'm going to actually just make a status to track the status of our promise. And at the very beginning, it's going to be pending, right? We accept a promise that is in flight. We're going to be, we'll start out with the status of pending. And then we don't need to create this promise anymore. We just need to attach our then handler. So we'll get rid of that. We'll say when that promise is finished, then this is going to be a resolved value. And I don't need to store the error or the result of this resolved value separately. So I'm going to have a single thing that I'm going to call the result. So this is going to be the thing that I'm going to throw, or throw in the case of it being an unresolved promise, or return if it is a resolved promise, or throw if it's an error. So I'm going to assign the promise to that result. We'll get that resolved value, and we'll say our status now, when it's resolved, is success. And the result we'll assign to the resolved value. And then we'll do a very similar thing for our error, where the result is going to be the rejection, and the status will be error. And then what I'm going to do here is return a function, or return an object that has a read function on it, where I can operate correctly. And that's basically what we're going to be calling right here. So I'll just move this up here. And so now, rather than just if there's an error, I can say if the status is error. And if the status is error, then I'll throw the result, because I know that the result is going to be the rejection. If the status is pending, then I know that the promise hasn't resolved yet, so I can throw the result in this case as well, because that result is the promise in this case. And then if the status is success, well, then I don't need to throw anything. I can just return the result, and I know that result is going to be whatever the resolved value was. And then finally, I can just throw a new error that's like, this should be impossible. That should never happen, because the status can't be one of those, or it can't be anything but one of those three things. But I like to add that in so that I just complete the way the code looks for me. So yeah, what value is this create resource? How do we use this now? Well, now I can say my Pokemon resource is equal to create resource with fetch Pokemon Pikachu. And I can say my Pokemon equals the Pokemon resource read. And that's it. So let's review this, because like if some of this is like, whoa, I just lost, I'm totally lost now. Don't feel bad. That was a lot of refactoring stuff. Let's review it so that we're all on the same page. So let's talk about like what happens from top to bottom as React is running through our code. So at some point we say, hey, React DOM, I want you to create a route and then render this to that route. And so React is like, okay, cool. So I'm going to render that. I need to go get the React elements that you need for this. And so, okay, it looks like you need a div, and inside of that div, you need another div, and inside of that div, you need an error boundary. So I'll just hang on to that. And then you've got a suspense boundary. Okay, I'll hang on to that. And here's the fallback for that. And then you've got this Pokemon info. Okay, I'll hang on to that. And now it's going to go into each one of these and get the React elements that they require. So the error boundary and suspense, like, oh, that's a built-in component, so I'll do my own thing with that. And then Pokemon info. So it comes into here and says, okay, let me find out what React elements Pokemon info needs. And so it calls this function. And before we even bother creating any React elements, we say, hey, Pokemon resource read. And so we'll go into the Pokemon resource read method, and we're going to come into here. And by the time we get to this point, we've already created the promise. We're already making the fetch request. We've already attached all these then handlers and everything. And so by the time we call read, we're still in a pending state, because this is, the asynchronous request to go get the data is probably going to take longer than it takes for React to get our component mounted. And so we're still in the pending, we're still in the pending state. So we're going to throw the result, which is that promise right here. So we're just going to say, hey, yo, I'm not ready to render yet. I don't have your data yet. And so as far as the Pokemon info component is concerned, by itself, it actually doesn't care about that. It does. This is one of the cool things about Suspense, and what's going to be great when you can use abstractions that are built on top of Suspense, is you don't have to worry about any of the asynchronous stuff for the code that you're writing. And this is like the exploded brain moment where it's like, oh, wow, now I get it. It means that I don't have to think about time. I don't have to think about my data requirements necessarily, not directly. I don't have to think about that loading state. I don't have to think about the error state. All of that's going to be packaged nicely into this abstraction for me. And I can make a really nice and declarative UI here that says, hey, if there's some sort of error anywhere from this part of the tree on down, then I'll go ahead and render this, whatever's in this error boundary. If there's some sort of loading state that happens, then I can declaratively say this is what should happen during that loading state. But as far as the code is concerned, I don't have to worry about, okay, we're in a loading state now, so render this. We're in an error state now, so render this. We don't have to do that. And that's what we do. This is the current state of the world, right? Is we have to manage all of this ourselves. And sure, we can make little hooks that'll do this, but at some point you have to get that error state and the data finished loading state, and you have to deal with that pending state, and you have to do all of this pretty imperatively in your own code. And so Suspense just removes all of that from our concern, so we don't have to even think about those. So we just assume that we have our data, and that's what's really cool about this API. So let's return to walking through this. So we say React says, hey, I want to render this Pokemon info. Give me the JSX elements, the React elements that we need to render. And we say, hey, I'm going to read my Pokemon because that's what I need. And then the resource says, yo, I'm not ready, not done loading this result. So I'm just going to throw it. And React says, okay, that's cool. I'll just find the closest error boundary to you, and I'll render its fallback instead. And I'll wait for that promise to finish loading. When that promise finishes loading, then it says, okay, cool. So it's either resolved or rejected. I don't really care. It's settled. And so now I'm going to trigger a re-render of everything under this suspense boundary, which in our case is just this Pokemon info. And so it goes through this again. And when we call Pokemon resource read, this time we have successfully loaded. And instead of throwing, we simply return the result, and we can render the UI. So that's a basic flow, and the error state is very similar. So we throw the promise, and then when it settles because there was an error, then it triggers another re-render. We come in here and we say, okay, let's we've got an error status, so let's throw that result. And React says, oh, okay, you threw, but it wasn't a promise this time. This time it's just like something else. So I'm going to hand it off to your error boundary to render what you want. So I just noticed, and by the way, you can feel free to ask questions as we go. There's like a 15-second delay between what you're watching and what I'm saying. And so it might be a little bit delayed, but feel free to ask questions, and I will endeavor to answer them as we go. This is totally fine. So Tim is asking, and I'm supposed to click on this and it'll pop up, but it's not. So I'll just read the question. So Tim is asking, does it make sense to nest error boundaries and suspense boundaries for different components? That's a great question. And my answer is basically, think of these boundaries as a try-catch. So with a try-catch, like I remember when I was doing Java stuff, there was this big joke where the product manager says, hey, we need to like manage errors in our app. And so you'd put a try-catch around your main method, like the start of your whole app. And you say, yeah, I got error management in my app, because like literally every error in your app would bubble up to that, barring any threads that you start or whatever. But so like it's funny because that wouldn't actually really work very well. You don't have enough information to recover from errors, or to in the context of UI, you wouldn't have enough information to display something useful to the user. If it was just like, there was some error in the application, refresh please, I guess. So think of React error boundaries and suspense boundaries as try-catch blocks, where you can provide more useful information the closer it is to the thing that you're trying to handle. At the same time, you wouldn't, right now the de facto standard for loading data is to put it right next to where that data is being loaded. And so that means that you handle the error and this success case in literally every single component. What ends up happening is you'll have like a million loading spinners when the user lands on the page, which is not a great user experience, and something that Suspense helps us do away with, because it allows you to say, hey, for this page, we're just going to let all of these things go get the data that they need. Like we can render multiple of these or multiple of components that suspend, and we'll just wait for all of them to finish loading before we actually start, before we render anything. And that, even though that means that maybe the user won't see some of the data as quickly, it does make the experience actually feel faster. And that's something that I go a lot more in depth with on Epic React Dev. So the next question from Hugo is throwing something that is not an error. I never think that as a possibility. Yeah, it's pretty amazing. Honestly, I remember the first time I saw that, I was like, this can't be right, but it is. And actually, as part of that, I just mentioned that this may not be the API when it's finished. I know that the React team isn't really satisfied with this. Personally, I'm not sure how else you could do this. How could you possibly make your render function look synchronous? I know that there are efforts to do this with generators, so make your components a generator. But once you add a generator anywhere in your call stack, everything has to be a generator. I don't like that. Generators never made sense to me. Maybe that's just a familiarity issue, but I've tried them several times, so I don't know. So I'm pretty happy with this API, especially since most people won't be dealing with this directly. And in Epic React Dev and in this workshop, this is the only place we do it. Everywhere else, we're just using this create resource API. So you never have to really look at it or really think about it. So yeah, Nick is asking, would this have much use for user event-driven fetch requests? Say clicking login button and switching that button's text with a spinner, where there's no need to fall back the entire component. Yeah, so in that situation, you would want to handle that that loading or pending status yourself. And that's the nice thing about Suspense, is that it's not an all-in thing. And you can say, hey, for this thing, I'm going to like handle this little loading spinner, but for everything else, I'll do Suspense. However, you actually can do this, and this is something we won't have time to get in today. But let's see. Let me see if I can find. I think it's. Let me just dive into exercise, maybe 4. It's probably exercise 3, but it's in here as well. So right here, we're using this hook called React Use Transition, and that allows you to show some sort of inline loading indicator while some suspending component is pending. So in a suspense world, this is probably what you'll end up doing. You'll say, hey, I'm going to start a transition. I'm going to do something that's going to trigger some loading state or some component to suspend. And so I want to know like how long that, or I want to know while that component is suspending so that I can actually render some sort of indicator. And I'll show you that here really quick, what that ends up enabling us to do. So here I can say, let's dim this while Charizard is loading, just to indicate to the user, hey, you're looking at some data that is a little stale. So yeah, that's definitely something that's that you're capable of doing in suspense land, which is pretty fun. Okay, great. Feel free to keep the questions coming. And I've got another like 24 minutes, so I am going to continue here with a refactor. So I've been showing you this like typical experience for a little bit, and we're going to refactor this to use suspense instead. So this works today. I can click Pikachu, I can go to Charizard, I can go to Mew, and this is all using React with use reducer and use effect and everything. I want to move this over to suspense so that I can have declarative pending and error states, and then this component can just assume success. Okay. So the way that this works right now is when I select one of these, or if I type my own in, then we handle that. We set the Pokemon name, and then we render the Pokemon info with that Pokemon name. And when that Pokemon name changes, then we trigger a fetch request. Okay, so the way that we want to do this is we want to actually start fetching that Pokemon as a Pokemon resource. And so before we had this create resource function, I actually have that in our utilities up here. So I'm going to grab, actually, hold on, where is that coming from? Yeah, that's coming from utils, not from Pokemon. So we're going to import create resource from this utils module. And that create resource is basically what we just wrote. And so as soon as we click on this button or submit a new Pokemon, then I'm going to create a new Pokemon resource as a side effect. So we'll say use effect. And we're going to depend on the Pokemon name to create this resource. And we're going to say fetch Pokemon with that Pokemon name. Okay, but if there's no Pokemon name, so like they cleared out the input or something, then we'll and then we don't need to really do anything. But we do need to do something with this resource. So I'm going to store that in state. I'll have a Pokemon resource and set Pokemon resource. We'll initialize this to null, so we don't have a Pokemon resource at the start. And so if there is no Pokemon name, then we're going to set the Pokemon resource back to null. So if they cleared out or something like that. But if there is a Pokemon name, then we're going to create a new resource and we'll set the Pokemon. You got to spell it right, otherwise it doesn't work. Set the Pokemon resource to that new resource we created. That'll trigger a re-render, and now we have a Pokemon resource that we can call read on, right, to get that Pokemon data. So this Pokemon info now, we're going to change this so that rather than rendering the Pokemon info if there's a Pokemon name, we actually care about the Pokemon resource now. And instead of passing the Pokemon name along, we're going to pass the Pokemon resource. Okay. And then we'll come up here, accept that Pokemon resource now. And now we can get rid of a silly amount of stuff. So we no longer need to care about the status or the error state or even the Pokemon state, because we're going to get that from our Pokemon resource. So now Pokemon is going to come from Pokemon resource.read, right? And this is going to be the thing that's responsible for throwing if we haven't resolved the promise yet, throwing if there's an error, or just simply returning that Pokemon value if we've resolved. So we're no longer needing to do this use effects stuff here. We're kind of moving some stuff over a little bit, but we're moving where we're moving it is actually a pretty awesome improvement. It's actually better for performance as well. If we were to lazy load this Pokemon info, we trigger this request earlier in the time frame. We don't have to have a waterfall effect where, okay, let's go get the code. Now we have the code. Let's execute the code. Now we executed the code. Now let's go mount this component. And now that we've done that, now let's go get the data. Instead, we say, let's go get the data, and let's also get the code while we're getting the data. So this can have pretty great improvements on performance as well. And then on top of that, we've moved it to something that's a little easier, straightforward, and we're also moving all of our loading and error states as well. So we no longer have a status we need to worry about. Instead, we're going to take this same fallback that we had before for the pending state, and we're going to render a React Suspense component with a fallback for that pending state. And we'll put the Pokemon info in there. So we've handled this case. And now for the error state, we can handle that. And I'm actually, instead of this, there was an error stuff, let's just get rid of that. We'll use our really awesome Pokemon error boundary instead. And so we'll put the Pokemon error boundary around all of this to handle any errors that happen. And the cool thing about this is now we're handling not only request errors for our suspending, the thing that we're suspending, we're also handling runtime errors as well, which is kind of nice. And now our Pokemon info component is only worried about the success state of this asynchronous request. And then everything else is handled by the parent as part of these different boundaries that we've set. Which means that these boundaries can handle just the single component by itself, or it can handle multiple components if we want to coordinate those loading states a little bit better. And so with this, let's just make sure that's all working, because that would be just really sad if it didn't work anymore. Yep, there we go. It is. So yeah, that's a basic refactor from an existing like regular use effect style like request of data to something that's more suspensey. So here we store the resource in state. We have a use effect that is triggered anytime the user changes the Pokemon name to create a resource to start fetching that Pokemon. And we set that into state, which will trigger a re-render. And now that we have that resource, we can actually render all of this UI, including that Pokemon info with that resource. And then it comes in here and it says, oh, I haven't actually, like that resource isn't ready to be read yet. So I'm going to throw the promise that resource is managing. React will wait until that promise settles, and then it'll re-render the Pokemon info component. And it'll either get its data or throw an error, which would be handled by the error boundary. So keep the questions coming. Just noticed a question from my friend Nick. What's up, Nick? All of this code is available to you on GitHub at kentc./React Suspense. And this instruction will be provided as like a tighter, more polished set of videos and exercises on Epic React Dev. So you can look forward to that too. But you can totally go through the whole workshop by yourself if you want to on that repo. And Anthony is asking, what API are you using to get the Pokemon data? Actually, it's kind of tricky. If you dive into here and look at the fetch Pokemon, we're using GraphQL Pokemon now.sh, and that actually totally works, except I'm hijacking window.fetch so that we don't actually make the network request locally. And that just makes it so that we can have all of this completely offline. But this totally works if you disable that particular feature. So yeah, it's kind of fun. So I realize that there's a 15-second delay. So if you just barely heard me saying, feel free to ask questions, then you can continue to feel free to ask questions. That's actually all I planned on sharing with you. Let me just double check. Oh, yeah, one other thing that I'll teach you about and then we can kind of wrap up. So feel free to send all your questions right now. But we were talking earlier about how we think about suspense boundaries and error boundaries, and like, should you just put them all together, or like, should you wrap every single component in a suspense boundary? And no, I wouldn't recommend necessarily doing that, but there are implications on where you position these different boundaries. So for example, if I put my error boundary around everything right here, and then there's some sort of error like anywhere. So if I type like whatever, some Pokemon that doesn't exist, ignore this thing. This is React scripts thing during development. This is what the user will see. They get everything just totally taken away, just disappears and gets replaced by what the Pokemon error boundary renders. Okay, and that is as opposed to where we had it before, which would, we're going to get rid of that thing, just replace the contents of this Pokemon info box here. So the positioning of your error boundary is pretty significant. Suspense boundary is exactly the same. So if we move this suspense boundary around everything, then it's kind of weird. We have a loading state that just replaces the entire app with this fallback. So that's something to keep in mind with like where you put these suspense boundaries. I wouldn't necessarily say every single suspending component should have a suspense boundary around it. That kind of reduces some of the value you get from suspense. But being like intentional about your suspense states is a good idea, and you can actually test that out in the React Dev Tools. If you look at your components and click on some component that can suspend, that has a suspense boundary above it, and then click the little suspense, the selected component, then that'll show you what would render if this component were to suspend for any reason. So yeah, that should help you be really intentional about your suspense boundaries. For your error boundaries, unfortunately, there's not really a great way to test that in the dev tools. That might be a cool feature to add if you want. But if you just want to test out your error boundary locations, then you can just throw a new error. Oh no. And that'll help you get an idea of what your error boundary states looks like as well. So yeah, suspense and error boundary position does make a difference. Okay, so I am going to go to answering questions, and yeah, and then we'll wrap this up. Any idea for when suspense will be stable? So ReactConf last year in October, suspense had been around forever. Facebook was announcing like their cool new UI and demonstrating it. And they had some suspense stuff in there, and it was really cool. And so I'm all thinking, yeah, this is coming pretty soon. And so I talked to some of the members of the React team, and I said my impression is that hooks was more along than suspense was, or the suspense is. So like at the time hooks was announced as like a beta feature or whatever, I thought that hooks was more done than suspense was at that time. And Sebastian said, actually, no, I think suspense is closer to being done than hooks was. I'm guessing that something else came up or something happened that made suspense take way longer. So I can't say anything about how close suspense is. It's been multiple years that they've been working on it and perfecting it, and things have changed from like not only their recommended way of using it, but also like the actual API. They've introduced some additional things like React Suspense List as a component, which we talk about in Epic React Dev. Yeah, like the use transition hook, that's totally different. So they've been listening to feedback from internally as well as externally and trying to deal with some of the problems and pitfalls that they see people making. So yeah, I have no idea on the timeline for that. So yeah, Tim's question is, if I understand correctly, one of the advantages of concurrent mode is to be able to interrupt rendering when your source data changes. How does suspense enable this? So Suspense and concurrent mode are related, but like pretty different. So concurrent mode does enable you to interrupt rendering, but that really like the main benefit of that is for prioritizing user interaction and responsiveness of your app over whatever other JavaScript things that your app is doing, or like rendering really heavy things. And what concurrent mode enables Suspense to do is it allows Suspense to well, it's kind of difficult to explain without taking you through the whole workshop. But one thing that you'll notice here is when I click on Charizard, look at the input, and you'll notice that it doesn't change right away. It actually takes just like a momentary second, or like a few hundred milliseconds before that change is actually recognized. And so what's happening is React says, oh, okay, you want to suspend. Well, I'm actually not going to do anything. I'm going to wait for a small amount of time so that you have some time to check into your cache or whatever you need to do to determine whether or not it's worth making a fetch request and whether it's worth rendering a loading screen. Okay, because the React team and Facebook, based on research that they've done, have identified the fact that if the user sees a flash of loading state, then that's the user perceives it to be slow. And so if they just wait for a short period of time for you to go check your cache, or maybe the asynchronous request is really fast, then there's no point in showing that loading state. And so React Suspense gives you all of these knobs that you can twist for like how long you want it to wait for that, or like how long, like allowing you to show us inline spinner during that pending state, like I was showing you with use transition. And so concurrent mode enables Suspense to do all of those things. Without concurrent mode, then Suspense wouldn't be able to interrupt that rendering cycle. So I'm not sure if that totally answers your question, but Suspense doesn't enable React to interrupt rendering. Concurrent mode enables that, and then Suspense leverages that capability. So Sritar is asking, should I write these fetchers, or would there be wrappers for Axios? Be a wrapper for Axios? So Suspense actually doesn't care about what asynchronous thing you're doing, and if you happen to be making HTTP requests, then that's fine. All that Suspense cares about is that you throw a promise. So that promise could resolve to like a Bluetooth API connection, or like if you're using the Bluetooth API in the browser, or requesting geolocation, or like any asynchronous thing that you want to do can be shoved into Suspense. Suspense is only concerned with accepting a promise, rendering some fallback, and when that promise resolves, triggering a re-render of the suspending component. So that's a basic idea. Anthony is, let's see, yeah, unrelated question, kind of meta question. Yeah, I think that's it for the questions. I'm just going to wrap things up, and feel free to shove a couple last minute questions in here, but we're pretty much done. So I'll just wrap up by saying Epic React has all of this and way more, all about React. So this is like my life's work. For the last year, I've thought about nothing else, basically. So Epic React is going to have React Suspense and fundamentals and everything to get you to a Epic React state. It is so enormous. So please do take a look at this. And if I convince you, then give me your email address to be notified of when this is ready. I think that Suspense is going to be a game changer for building applications. And it will be especially useful for libraries and frameworks that will leverage them to make your code really straightforward to author and to maintain in the long term. So you don't have to worry about you can just assume that your data is always there. And these libraries and frameworks will make sure that that you can that all works, thanks to how Suspense works. And in addition, concurrent mode is going to make it so that your app is more responsive when you're doing really heavy lifting with your components. So I'm really excited for this to become official. I have been for years now. But yeah, that's pretty much it. It doesn't look like we have any other questions coming in. So I'm just going to wrap this up and say thank you very much. And I'll see you around on the internet. And I'll just wait for my host to come back.